So our lesson objective is I can find slant asymptotes of rational functions. So when the degree of p of x, so remember f of x is p of x over q of x. So when the degree of p of x is exactly 1 more than the degree of q of x, the graph will have a slant asymptote or an oblique asymptote, which is this right here. So the equation of the oblique asymptote will be y equals mx plus b. Specifically, it's going to be a linear function, and it is the quotient of p of x over q of x, ignoring the remainder. So here are the steps to find the equation of the slant asymptote. It might not be super... okay, perfect. So you can use synthetic or long division to divide p of x by q of x, and then write the equation of the oblique asymptote using the quotient, ignoring the remainder. Here we have to find the equation of the oblique asymptote, so we're going to use synthetic division. We have -4, divide by 1, and then we have -1, -14. Bring down the 1. 1 times -4 is -4. -1 plus -4 is -5. -4 times -5 is +20. And then -14 plus 20 is 6. So what you do here is you ignore the remainder, and your oblique asymptote will be y equals x minus 5. So you take your x value, your constant, and then the remainder. Here we have 3x squared minus 7x divided by x minus 3. So we're going to synthetically divide. So we include a 0 here for our constant. So we're going to first bring down our 3. 3 times 3 is 9. -7 plus 9 is 2. 2 times 3 is 6. 0 plus 6 is 6. This we ignore. So our oblique asymptote is y equals 3x plus 2. Here we have 6x squared plus 4x minus 11 over 3x minus plus 2. And what I'm actually going to try here is I'm just going to do long division. Okay. All right, so 3 times 2 is 6, so we're going to multiply by a 2, and then we need an x. So we have 6x squared plus 4x. This cancels, so we have -11. And then we don't have any values that we can add here, so we can stop here. And what we'll do is then just say y equals 2x. Here we have x cubed plus 3x squared over x squared plus 2x minus 3. So we're going to multiply by x squared because we're going to multiply by x because x squared times x is x cubed plus 2x squared. So then we'll have x squared, and we can multiply by 1. So we'll have x squared plus 2x minus 3. We'll end up with -2x plus 3. So we'll ignore this, and our asymptote is y equals x plus 1. Here we have to graph. We have x squared minus 9 over x. So we're first going to figure out our slant asymptote. I'm going to do x divided by x squared minus 9. And so this goes in first x times, so this is x squared. We can subtract that away, and we have -9. And then we can stop here. So we know we have a slant asymptote at y equals x. So we go ahead and draw the slant asymptote, and then we go ahead and just figure out the rest of the graph as we would before. So there's no horizontal asymptote, And then the vertical asymptote is x equals 0. There will be no holes because nothing got canceled. The y-intercept. So in this case, we're going to have none because we have our vertical asymptote at x equals 0. And then we have an x-intercept we have x squared minus 9 equals 0. So x squared equals 9. So x equals plus or minus 3. So we have 3 comma 0 and negative 3 comma 0. And then because the lines abide by these two others, we can, because our function abides by our asymptotes, we can actually go ahead and draw our graph at this point. And then the way this works for the domain is the domain's actually going to be the same. We do negative infinity to 0, union 0 to infinity. And then the range will be negative infinity to positive infinity because it includes all values. Again, also because we don't have a horizontal asymptote. So now what I'm going to do is just graph this on a graphing calculator to make sure it's right. So here we have our graph, and that looks pretty much the exact same to me. So yeah, we did that right. Here we have f of x equals 2x squared minus 3x minus 20 over x plus 1. So we're going to use synthetic division to figure out our slant asymptote. So we have negative 1, then we have 2, negative 3, negative 20. Bring down the 2. 2 times negative 1 is negative 2. Negative 5. Negative 1 times negative 5 is 5. So we have negative 15. We ignore that. Our slant asymptote is y equals 2x minus 5. So we go ahead and we graph that. So we go to 0, comma, negative 5 first. We go up 2 to the 2 up to the right 1, 2 up to the right 1. And we just continue the same process. You also can go down 2 to the left 1, and then just draw a dashed line to indicate that it's an asymptote. So then our vertical asymptote, we have x plus 1 equals 0, so x equals negative 1. We have, for the horizontal asymptote, the degree of p of x is greater than the degree of q of x. So we have none. We have no horizontal asymptote. And then our x-intercepts, we're going to set our numerator equal to 0. And we'll do that on the next page, but just know the x-intercepts will be negative 2.5 comma 0 and 4 comma 0. I just don't have enough room on this. The y-intercept will be f of 0, which is going to be negative 20. So it's going to be 0 comma negative 20. We already have the slant asymptote, which is y equals 2x minus 5. And then we don't have any holes in our graph, so we can go ahead and graph this. So we have, this is where our vertical asymptote lives. And so then we have negative 2.5 comma 0, and we also have 4 comma 0. So we can guess our graph will look something like this. Not right. And if you notice, as you go through this more, you really rely less on values of x and more so on just the asymptotes. And then for our domain and range, the domain is negative infinity to our vertical asymptote, which is negative 1, and then negative 1 to infinity. And then our range is negative infinity to infinity because we don't have a horizontal asymptote. And then just to set this equal to 0 and show you how to find the x-intercept, so we can multiply this negative 2 and 20 together to get negative 40x. So we need two numbers that add to -3 and multiply to -40. So that's going to be -8 and 5. So this will be 2x squared minus 8x plus 5x minus 20 equals 0. Factor out a 2x, we have x minus 4. And then we factor out a 5, we have x minus 4. And so we end up with 2x plus 5 times x minus 4 equals 0. So if 2x plus 5 is 0, 2x is 5. So x is 2.5. And then if x minus 4 equals 0, x equals +4.